Hello class, thank you so much for joining me today. So where we left off last time is we figured out how to determine how many workers a particular firm was willing to hire at a particular wage and how many workers an industry was going to hire at a particular wage in the short run, which is to say when the firm only really has one way to produce a certain amount of output because they only have one input that they can change. In other words, either we're going to talk about firms that only use labor in production or firms that have some fixed amount of capital that they aren't going to be able to change in time to make their decision about how much to produce and how many workers to hire, right? We talked about the ripe strawberry field where the land has already been cultivated, the strawberries have been planted, your only decision is how many people to send out to harvest strawberries. Wow, awesome. So what we're going to be doing today is extending this by thinking about labor demand when firms have multiple inputs that they're able to change, right? So when firms are deciding not only how much to produce, but also whether to use workers or use machines to accomplish certain tasks, and how that's going to change our decision-making framework. We're going to be able to use this same framework also to think about other contexts where we have multiple inputs in production. So thinking about workers with different skill levels or different histories in the United States is going to also fall into this framework. This is going to be useful for a whole range of different questions that we're going to care a lot about, right? We're going to use this analysis that we do today to think about things like how immigration is going to affect the employment and earnings of native-born workers. It's going to affect questions like how globalization is going to affect wages, how it's going to affect wages of workers with different skill levels. Even things like how much we might expect minimum wages to affect employment in the short run compared to the long run, right? Or what types of occupations are likely to be most or least negatively affected by a change in minimum wages because of different elasticities of demand. So this is going to be a very broadly applicable set of tools we're going to learn today. So to do this, let's go back to our simple profit maximizing firm, right? It's deciding how many workers to hire at a constant wage rate W, how much capital to hire at a constant rental rate R, and how much output to produce and sell at a constant price P, right? So as we talked about last time, this firm's going to have a profit function, right? It's going to be equal to the price times the amount of stuff that they make minus their costs, right? Which is going to be WL plus RK minus the cost of output. And we're going to say that this Q is going to be given by a production function, right? F of LK. Now, when we talked in the short run, we said that there were two ways that we could figure out how many workers this firm was going to want to hire, right? At a wage rate W, rental rate R, and price P. We said that we can do so indirectly or we could do so directly. So doing so directly would be to find the marginal product of labor, right, of L and K, which is going to be the FDL, and multiplying this by the price to find out the extra dollars produced by each additional worker. Right, setting that equal to our wage rate. And from here, right, figuring out the number of workers we want. The problem now is this is going to be very challenging to do because our marginal product of labor is likely to depend on the amount of capital that we decide to buy, right? If we buy a lot of machines, that might make workers more productive or it might replace workers, right? Make workers less productive. In either case, we're not going to be able to solve this just as a function of L. Now we could do exactly the same thing with the marginal product of capital, create a system of equations where we also have a marginal revenue product of capital in terms of L and K equal to price times the marginal product of capital. Set that equal to the rental rate, right? And then have two equations, two unknowns, L and K, solve like that. But that's going to end up being a little bit more trouble than it's worth. And it's not going to give us as useful of intuition as we can by solving this problem indirectly. So as a result, instead of doing this, what we're going to do is first figure is basically break our problem into two sections, just like we did in Econ 250, where we're going to start by thinking through a cost minimization problem, right? Given a certain amount of output that we'd like to make, given a certain Q, what combination of labor and capital is going to be the cheapest possible way to make that Q? And then once we've done that, figure out our profit maximization problem, right? If we know the cost of any given amount of Q, how much will we produce before an additional unit is more expensive than it brings in revenue. So that's basically the strategy we're going to take. So our strategy, right, just to highlight this, our strategy is going to be the first, find cheapest way to make Q units of output. And then second, find most profitable value of Q. Cool. So we're going to start with this first chunk here, right? How are we going to make our Q units of output as cheaply as possible? And the basic idea here, right? The basic challenge is that when we have multiple inputs, right, in this case labor and capital, we're going to have multiple options, multiple combinations of labor and capital that are able to produce exactly the same amount of stuff, right? In other words, if we graphed L and K, right, we wanted to know what combination of land and strawberry pickers are going to allow us to get to 10 tons of strawberries, right? Maybe we could do that with lots and lots and lots of land and a really small number of pickers, right? Once there's a full ripe field, we can just basically send people in. They can be super inefficient, squish a lot of the strawberries, and still end up with a lot of stuff, right? So we can have lots and lots of land and only a small number of pickers. We can also have lots and lots of pickers and a really small amount of land, right? Send people out to very carefully and gingerly make sure that they get every single available strawberry. Maybe we could also do it with something in between, right? Moderate numbers of workers, moderate amounts of land. So we could end up with a whole range of different possibilities, right? Whole range of different combinations of labor and capital, all of which are going to get us to 10 units of output. Make sense? This hopefully looks a little bit familiar to you. So our question then, right, when we're trying to figure out our minimum cost, is which of these options, right, which of these ways of producing 10 tons of strawberries is going to be the cheapest possible for us. The way we're going to do that, right, is we're going to say, well, let's think about all the combinations of labor and capital that have the same cost, right? So we're going to call this an isoquant. And then we've got our isocosts, which are going to be combinations of labor and capital, which cost the same amount. These are going to end up being straight parallel lines with a slope of W over R. The reason for that is, right, each worker costs W, each unit of capital costs R. So if we're trying to figure out the combinations of labor and capital that all cost, say, $100, that's just going to be a straight line with a slope of W over R. Cool. So what's our cheapest option going to be? Our cheapest option is going to be the lowest isocost curve that touches our isoquant in just one place. So as long as we're using both labor and capital, right, as long as we have an interior solution, our cheapest option is going to be a point like this that has two properties, right? It has an MRTS, which is the slope of our isoquant, equal to W over R, and it's on our isoquant. Hopefully, again, this looks a little familiar because I'm really just blazing through this, right? We spent days on this in Econ 250. So when we have an interior solution, right, meaning we use both L and K, we're going to have two things. We're going to have our MRTS of L and K, which is equal to dF dL over dF dk. Is going to equal our cost ratio, W over R. And we're going to have the right amount of L and K to produce Q units of output, right? So, and we're going to have our desired Q equal to F of L and K. Wonderful. So let's go through a concrete example, right, with a particular formula, so that we can just remind ourselves of this and get a little bit comfortable with this math. So to take an example, let's imagine that our strawberry orchard has the following production function in terms of labor and capital. We've got F of LK equals, let's just make this simple, L to the 1/3 times K to the 1/3. Good? And our goal, right, is to find the right amount of L to produce Q units of output and the right amount of K to produce Q units of output, in addition to the cost of producing Q units of output. Right, so we're trying to figure out this point right here, where we're producing some amount of output Q in the cheapest way possible. So how are we going to do this? We're going to find our MRTS. Which is just going to equal, right, dF dL over dF dk. Now what's dF dL going to be? Derivative of this thing with respect to L is going to be 1/3 times L to the 1/3 minus 1, which is negative 2/3, times K to the 1/3, right, all over derivative of this thing with respect to K, 1/3 L to the 1/3, times K to the 1/3 minus 1, negative 2/3. And as you may remember from 250, this ugly, horrible thing magically transforms into something beautiful and lovely because the 1/3s cancel out. L to the minus 2/3 we bring down to get L to the 1/3 plus 2/3. Bring the minus 2/3 up, so this becomes just K over L. Ah, amazing. What do we do with this? We say, well, we're going to set this equal to our cost ratio. Equals W over R, right? K over L equals W over R, which we can use to find K in terms of L. Right? The ratio at which we're going to use agricultural land and agricultural workers. So this is our first piece here, right? MRTS equals W over R. The other thing we need to figure out the right levels of K and L is we need to make enough stuff, right? We need to make Q units of output. So the second thing is produce Q units, right? Which we can do by saying, well, Q is going to equal L to the 1/3 times K to the 1/3, right? We can plug this in for K. So we'll say Q is going to equal L to the 1/3 times W over R times L to the 1/3. So Q is going to equal W over R to the 1/3, L to the 2/3, which will tell us, right, that L is going to equal Q divided by W over R to the 1/3, right? So Q times RW to the 1/3. This is going to be L to the 2/3. So L is going to be R over W to the 1/3 times to the 3/2, right? Which is going to be to the 1/2 times Q to the 3/2. Lovely. So that's our L star. Right now we just need to find our K star, which we can do by remembering that K equals W over R times L. Right? So we can say K is going to equal W over R times L, which is going to be W over R times R over W to the 1/2 times Q to the 3/2. And with the magic of algebra, right, we can say WR times R over W to the 1/2 is going to be W over R to the 1/2, right? W over W to the 1/2, R to the 1/2 over R. So this is going to mean K is going to equal W over R to the 1/2 times Q to the 3/2. Let's take a moment to stop and see if our answers make sense. What we're saying is, right, the amount of labor we're going to use, bigger the more we're producing, makes sense. Smaller the higher the wage of workers is, makes sense. And higher the more expensive land is, also makes sense. Right, amount of capital we're going to use goes up when workers are more expensive, good. Goes down when land is more expensive, good. And goes up when we produce more stuff, good, good, good. So as we said, right, these are the first two things we wanted, is K and L. The last thing we want is to know the cost of producing unit of output, which we'll use to figure out whether each unit of output is worth producing. How can we do that? Well, our cost is right here, right? We know that the cost of producing Q is just going to be W times the L that it takes, plus R times the K that it takes, which means that our C of Q is just going to be W times L star. Right, plus R times K star. Right? Sorry. Doing my best with this tiny board. Right? We can then mush all this together, right? We've got W divided by W to the 1/2. So we can say that C of Q, this is going to become W times R to the 1/2 times Q to the 3/2. Same thing here, R divided by R to the 1/2 is R to the 1/2. So this becomes W times R to the 1/2 times Q to the 3/2. Which means this whole thing mushes together into one beautiful function, where we can say the cost of producing Q stuff as cheaply as possible, WR to the 1/2 times Q to the 3/2 plus WR to the 1/2 times Q to the 3/2, which is 2 times WR to the 1/2 times Q to the 3/2. Lovely. Okay. So this is what we wanted to do, right? We're able to find our L of Q, our K of Q, and our C of Q. Wonderful. So at this point, right, we know the number of workers that we'd like to hire, given a certain amount of output that we'd like to produce, right? Likewise, we know the amount of capital we hire, we know the total cost of producing the output. So this is close to what we ultimately want, right? We said this was our goal, but that was just our medium-term goal. Our long-term goal is to know how many workers the firm's going to hire given wage rates and rental rates and prices, right? So what do we have to do to get from here to there? We have to figure out the right amount of output to produce, right? Once we know Q, we're going to be set, right? We're going to be so happy. So how are we going to figure out our Q? Well, what we're going to do is we're going to say the firm's optimal output is going to be the output that maximizes its profits, right? So we know the profits, as we said before, in terms of Q, are going to be the price times the amount of Q minus WL plus RK, which I'm just going to call C of Q, right? That's the cost of producing output in the cheapest way possible, minus C of Q. So a particular unit of output is going to be worth producing as long as the price we get for it is higher than the change in the cost that we need in order to produce that output, right? In other words, we're going to produce as long as our price is higher than our marginal cost. What's this going to look like? We've got a constant price P, right? If we've got a marginal cost that's getting higher and higher and higher as we produce more stuff, where the marginal cost is a change in cost from producing additional units, it's going to be worth it to produce a couple of units, right? A few tons of strawberries, and then eventually it just becomes more trouble than it's worth, right? We're going to want to stop here, not produce additional strawberries here. Cool. So our rule is going to be produce until price equals marginal cost. Wonderful. So in order to do this, all we have to do is figure out our marginal cost. Marginal cost, we'll call MC of Q, right? As I've said a couple times, just the change in cost that comes from changing the amount of stuff we produce. Changes are derivatives, right? So we're going to say marginal cost of Q is going to equal the change in the cost with respect to Q. Now, in this case, we have a cost function given right here, right? So we're going to say marginal cost in terms of Q is going to be the change in 2 times WR to the 1/2 times Q to the 3/2, right, with respect to Q, which is fortunately going to be a fairly straightforward thing to do. Why do I say that? Because this is just some number, right? 2 times W and R, which we don't have any control over, times Q to the 3/2. How do we take the derivative of some number to a power? Or some number times our variable to a power? We just pull down the power, right, subtract 1. So we're going to say our marginal cost in terms of Q is just going to be 3/2 times 2 WR to the 1/2 times Q to the 3/2 minus 1, which is going to be Q to the 1/2, right, which is going to be just 3 WR to the 1/2 times Q to the 1/2. Lovely, 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 lovely. So now we find our Q, right, by just setting this marginal cost equal to price. And solving for Q, right? So we can say Q to the 1/2 equals price over 3WR to the 1/2. Q is going to be P squared over 9WR. Lovely, 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 right? So now we know how much to produce, given a price, given a wage rate, given a rental rate, right? It's just going to be, we're going to produce more the more expensive strawberries are. Good, good, good. We're going to produce less the more expensive the inputs required to make strawberries are. Also good. Okay, great. So are we done now, right? We finally gotten through a whirlwind tour of some of the math you hoped you left behind in a life you hardly remember. Have we gotten to the labor demand of the firm? Not quite yet, right? This has told us how much we produce. If we were in producer theory, that's all we care about, right? But we're labor economists. What we care about is the number of workers that are going to be hired. So we've got one last step, which is we've got to plug this Q star into our L star to figure out labor demand. So right, we're going to say labor demand in terms of Q and in terms of W, R, and P, right, is going to be R over W to the 1/2 times Q to the 3/2. And Q is this, right? P squared over 9WR. We just plug this into there. And we say our labor demand in terms of our wage, rental rate, and price, right? All of the sort of prices relevant to the firm's decision. It's just going to be R over W to the 1/2 times P squared over 9WR to the 3/2, right? So this is in turn going to be P squared to the 3/2 is going to be P cubed. Right, 9 to the 3/2, square root of 9 is 3, cubed is 27. WR to the 3/2 each. Right, I'm dividing by W to the 1/2 and W to the 3/2, that becomes W squared. I've got R to the 1/2 divided by R to the 3/2 is going to become R. Right, so I'll say L star. Our final answer to this question is going to be P cubed divided by 27 W squared times R. Whew, wonderful. Okay. So we did it, right? It took a couple boards worth of math, but we managed to make our way to figuring out the labor demand curve for a particular firm, right? Given their production technology, given the price of their outputs, and given the cost of their other inputs. And based on this answer, we can see that for this production technology, which I picked for mathematical convenience, right, if land got more expensive, the firm would want to hire fewer workers. So at least in this case, we can get this sort of sense that maybe labor and capital aren't totally enemies. But so far, you might be feeling just a little bit unsatisfied with what we've done. Because all we've done so far is take you through a somewhat difficult math problem that you've already struggled with, right, to get very little insight. So what we're going to do next is we're going to take this math problem and break it up, right, use the mechanics of the math problem we just did to break this up into a couple of chunks. They're going to help us answer these motivating questions we started with about things like how long-run and short-run minimum wages are going to be different, and how long-run technological change is likely to affect demand for different types of workers. Cool.